Units and dimensions. Units and dimensions. Fundamental units in different systems. Fundamental units in different systems. In CGS system, the fundamental units are centimeter, gram, second. In CGS system, centimeter, gram, second. In MKS system, meter, kilogram, second. Meter, kilogram, second. In FPS system, foot, pound, second. In FPS system, foot, pound, second. Conversion of units. Conversion of units. 1 meter is 100 centimeters. 1 meter is 100 centimeters. 1 kg is 1000 grams. 1 kg is 1000 grams. 1 inch is equal to 2.54 centimeters. 1 inch is equal to 2.54 centimeters. 1 foot is equal to 30.48 centimeters. 1 foot is equal to 30.48 centimeters. 1 lb is equal to 453.6 grams. 1 lb is equal to 453.6 grams. 1 radian is approximately 57.3 degrees, 57.3 degrees, or pi radians is equal to 180 degrees. Some derived physical quantities and their units. Some derived physical quantities and their units. Area, its unit is meter square. Volume, its unit is cubic meter, meter cube. Density, kg per meter cube. Velocity, meter per second. Acceleration, meter per second square. Momentum, kg meter per second. Force, Newton. Work or energy, joule. Power, watt. Angular velocity, radian per second. Angular acceleration, radians per second square. Moment of inertia, kg meter square. Angular momentum, kg meter square per second. Torque, Newton second. Pressure, newtons per meter square. Dimensional formula and dimensions. Mass is represented by capital M. Length is represented by capital L. Time is represented by capital T. Current by A and temperature by K. And the dimensional formula for work is m to the power of 1, L to the power of 2, T to the power of minus 2. Here we say the dimensions of mass in work is 1. The dimensions of mass in work is 1. The dimension of length in work is 2. The dimension of length in work is 2. The dimension of time in work is minus 2. Minus 2. Like this we define dimensions. We represent a physical quantity, derived physical quantity in terms of fundamental physical quantities using the symbols m, l, t, a, etc. and then their powers will be taken as dimensions. In general, if there is a physical quantity with a dimensional formula m to the power of a, L to the power of b, t to the power of c, a to the power of d, k to the power of e, in general we have a derived physical quantity which is represented by m to the power of a, L to the power of b, t to the power of c, d to the power of a, k to the power of e. Then we say the dimension of mass is a, the dimension of length is b, the dimension of time is c, the dimension of current is d, and the dimension of temperature is e. Like this we take the dimensions. Now let us derive the dimensional formulae. Velocity is defined as rate of describing displacement. So displacement by time, that is L by T. Displacement is represented by L and time is represented by T. So it is L by T, or it is written as Lt to the power of minus 1. Acceleration is change in velocity by time. So dv by dt. Velocity or change in velocity will be represented by Lt to the power of minus 1. Hence time is represented by t. So this becomes Lt to the power of minus 2. dv is Lt to the power of minus 1, dt is t. So it is Lt to the power of minus 2. Then momentum P is equal to mv, where m is mass, v is velocity. So capital M into Lt to the power of minus 1 is the dimensional formula for momentum. Force is mass into acceleration. Force is mass into acceleration. Then it is mL t to the power of minus 2. mL t to the power of minus 2. Then work is force dot displacement. Force into displacement. So mL t to the power of minus 2 into L, that is mL square t to the power of minus 2. Power is rate of doing work, W by T. So which becomes equal to mL square t to the power of minus 3. Pressure is force by area, that is mL t to the power of minus 2 divided by L square, which becomes equal to m L to the power of minus 1 t to the power of minus 2. Derivation of dimensional formulae for some constants. So let us take the relation for force, gravitational force F is equal to g m1 m2 by d square. So capital G is equal to F d square by m1 m2. F is force and d is displacement, m1 m2 masses. By substituting their dimensional formulae, we will get the dimensional formula of G as m to the power of minus 1, L to the power of 3, t to the power of minus 2. G is F d square by m1 m2. F is force whose dimensional formula is mL t to the power of minus 2. D square is L square because it is distance. Masses are m into m. On simplification, it becomes m to the power of minus 1, L to the power of 3, t to the power of minus 2. Force constant. This is force acting over unit length. Force constant is force acting over unit length. So it is F by m. So by derivation, F is mL square t to the power of minus 2 divided by m represents length. So mL t to the power of minus 2 by L, which becomes equal to m t to the power of minus 2. If you want the dimensional formula for period t, the dimensional formula for period is t, then for frequency n is equal to 1 by t, hence the dimensional formula of frequency becomes t to the power of minus 1. Dimensional formulae in rotational dynamics. Dimensional formulae in rotational dynamics. Theta angular displacement is equal to S by R, arc length by radius. So its dimensional formula is m to the power of 0, L to the power of 0, t to the power of 0. Angular velocity omega is equal to theta by t, angular displacement by time. So its dimensional formula, omega dimensional formula becomes m to the power of 0, L to the power of 0, t to the power of minus 1. Alpha angular acceleration. This is change in angular velocity by time. Hence, the dimensional formula of alpha becomes m to the power of 0, L to the power of 0, t to the power of minus 2. M to the power of 0, L to the power of 0, t to the power of minus 2. I, moment of inertia, its formula is mr square, where m is mass, r is radius. So its dimensional formula is ml square. Dimensional formula of I is ml square. Angular momentum L, its formula is I omega, where I is moment of inertia, omega is angular velocity. Hence, the dimensional formula of angular momentum is ml square t to the power of minus 1. Torque. Torque formula is I alpha, I is moment of inertia, alpha is angular acceleration. Hence, the dimensional formula of torque is ml square t to the power of minus 2. Dimensional formulae in properties of matter. Surface tension is equal to force by length. So its dimensional formula becomes m t to the power of minus 2. Force constant K is equal to force by length F by x. So it is also equal to m t to the power of minus 2. Stress, force by area, which becomes equal to m L to the power of minus 1 t to the power of minus 2. Strain, E by L, change in length by original length, hence it becomes dimensionless, m to the power of 0, L to the power of 0, t to the power of 0. Velocity gradient, change in velocity by distance between the two layers, dv by dx, change in velocity by displacement. So it becomes t to the power of minus 1. Eta, coefficient of viscosity, F divided by A into dv by dx. So by substituting the dimensional formula force, area, dV by dx, we will get the dimensional formula for eta is m L to the power of minus 1 T to the power of minus 1. Dimensional formulae of some physical quantities in heat. Q is energy. So, its dimensional formula is ml square T to the power of minus 2. From Q is equal to mc theta, specific heat theta is equal to Q by mc. So, the dimensional formula of specific heat C becomes equal to L square T to the power of minus 2 K to the power of minus 1. Thermal capacity, it is mc, mass into specific heat. Hence, its dimensional formula is ml square T to the power of minus 2 K to the power of minus 1. Latent heat L is equal to Q by m, because Q is equal to ml. Therefore, dimensional formula of latent heat L is L square T to the power of minus 2. Coefficients of expansions. Coefficient of expansions alpha, beta, gamma. Their unit is per degree centigrade. Hence, the dimensional formula becomes K to the power of minus 1. The dimensional formula becomes K to the power of minus 1. From the relation PV is equal to nRT, R is equal to PV by NT, from which if we derive, we will get the dimensional formula for R as m L square T to the power of minus 2 K to the power of minus 1 mole to the power of minus 1. The dimensional formula of R is m L square T to the power of minus 2 K to the power of minus 1 mole to the power of minus 1. E is equal to half kT, where K is Boltzmann constant, E is energy, T is temperature. Hence, the dimensional formula for K becomes equal to ml square T to the power of minus 2 K to the power of minus 1. ml square T to the power of minus 2 K to the power of minus 1. The dimensional formula for sigma will be obtained from its unit, which is watts per meter square per Kelvin to the power of 4, because energy radiated from the unit surface area per second from a black body is given by E is equal to sigma T to the power of 4, from which we will get the unit of sigma is watts per meter square per Kelvin to the power of 4. The dimensional formula of watts power is ml square T to the power of minus 3. That of area m square is L square. Temperature to the power of 4 is K to the power of 4. Hence, the dimensional formula of sigma becomes ml square T to the power of minus 3 divided by L square K to the power of 4, which is m T to the power of minus 3 K to the power of minus 4. The dimensional formula of sigma can be derived like this. It is m T to the power of minus 3 K to the power of minus 4.